Okay, so it's 1:30 and it's time to start this session. So hello everyone, it's my pleasure to welcome you to the ACEMS Industry Career Presentation session. And I'm Luca Maestrini from University of Technology, Sydney. I'm sharing this session together with Angela Dalke, our ACEMS Stakeholder Engagement Coordinator. And Angela helped us a lot organizing the retreat, and also she helped us connect with the speakers, the incredible speakers for this session. So we are very excited to have you here all today, and we are very excited to have three excellent speakers from the industry. We have Ruth Luscombe from Fireball International, a tech company addressing the problem of wildfires. Sharon Aude from Australian Post, which delivers innovative data solutions, not just posts. Aude Vignelles from the Australian Space Agency, creating a universe of opportunities, particularly for quantitative scientists. So each of our speakers will present for 15 minutes, and after these we will have time for questions, for a Q&A session. I also invite you to stay connected after the industry panel session, and we will have a short tea break running from 2:30 p.m. to 2:40 p.m. Sydney time. So I think it's now time to start. And firstly, let us welcome Ruth Luscombe. Ruth is a mathematician and data scientist. She has a PhD in mathematics from QUT and has a lot of experience in project management, machine learning, programming, and solution development in health, education, and private sectors. Currently, she is a technical product manager at Fireball International, a tech company that uses satellite and ground-based sensor data for early wildfire detection, assessment, and mapping. Okay, Ruth, the floor is yours. Welcome, Ruth.
Thank you. I guess I can share my screen. All right. Can someone confirm that you can see my presentation?
Yes, we can.
Right.
Excellent. Thanks for inviting me along. I think I saw some familiar faces from my time at University of Melbourne and my time at QUT. It's nice to get invited along to these things to talk about what happens when you leave academia. And I also feel like every time I come back and talk at the universities that I have a new job. So this year it's early bushfire detection, which is kind of exciting. I always think that it was a complete serendipitous accident that I ended up doing mathematics. There's lots of cool sciences out there, but it just so happened that at high school it was my maths teacher who was the best teacher. So kind of why I ended up doing maths, which then turned into, I think I ended up doing operations research as a specialization. And then ultimately it morphed into what is now data science. So it's been an interesting and fun journey, but I sometimes wish that I'd done something as cool as astrophysics. I think a fun fact for me as a data scientist now is that many of the really brilliant data scientists I work with actually came to data science from a graduate degree in astrophysics. And you probably recognize the donut picture from the Event Horizon paper of, was it just last year or was it the year before? But from the distant past, I guess. And a fun fact about this is there was a guy on my previous team at my previous employer who was on the very, very long author list for this paper. So yeah, sometimes I feel like physics might have been a cool alternative to study. But this is my path. So I started my undergraduate degree in the early 2000s. And then when I graduated in 2005, I spent a few years doing a few different things before I actually landed before I properly wandered back to proper maths jobs. And I worked in hospitals for a little while doing analytics. And that led me to do my PhD, which is dynamic scheduling in emergency departments, dynamic resource allocation. And then when I graduated, I did a few more contracts. I actually went back to the hospital and I did some rostering work there. And then what I realized or started to realize was that this cool thing that started to get really big that was called data science, because I think that was around, like it was only about 5 years ago that we started really talking about data science, and then people started getting really cool jobs in data science, and that these became really big buzzwords. I really think it's only been in the last 5 years. So I found myself with the right sort of skills. Towards the end of 2017, I had a job that wasn't working out. So I took myself away on a sabbatical to Bali, and came back rebranded as a data scientist after having, you know, gone and done the research or done some of the courses that you can do around the foundations of machine learning. And I've had some really cool jobs since I've come back. And I did notice there was a little bit of a theme, not a theme so much, but something that had come up in the previous talk about how do you go and get those jobs? And I can say, like, the last time I went to and got a job based on an interview with a bunch of strangers was that first job in 2010 at Queensland Health. Like, it's been a long time since I didn't get introduced to a company, or either through a friend who became a colleague, or, you know, be at some event where some person from a company was looking to hire some quantitative skills. So make sure that you, I don't know, go to hackathons with your friends, just in case you meet someone from a different business. Go to meetups, just in case someone gives a cool talk and then at the end they say they're hiring. And, you know, when your friends leave grad school, stay in touch with them too. You know, and there's, for those of you who know Sam Clifford, who used to be at QUT, there's been times when each of us has emailed the other one going, you know, are you looking for work? Because I'd love to have you on my team. So, you know, we stay in touch with all our friends, and this is how we get work. And the job that I have right now, the way I got this job was at around Christmas time. I was at a Christmas party for the Pridgeon Digital Hub, where there's a meetup group that I sometimes help organize, and where I currently am based for work. But they had a Christmas party, and at that Christmas party, I met the two people who are now my bosses. So who knew? And this job with Fireball, it's quite a cool company. The broader part of Fireball, so Fireball Technologies, has been around for 20 years because there's this old firefighter in Nevada who also has a pilot license. And so he mounts cameras on his planes and flies over fire fronts, and then sits down with ground control and maps out what's probably going to happen the next day. But Fireball International is taking some funky satellite and camera data and turning it into digital maps and electronic notifications so we can do it in real time. And the picture here on the left is actually the fires that were in Pridgeon last summer. And the picture was taken from the balcony of the apartment where I live. So bushfires are a thing, and it's really cool to have found my way to working on such a cool problem, because like, there's quantitative problems everywhere in every industry. And the last job I had, as cool as it was, the people I was working with, and you know, the technical value in the work that we were doing, that was for the mining industry. So at Christmas time, when I met some people who were like, we need basically the same technical skills, but to do something as relevant and close to home as early detection of bushfires, it was pretty easy choice to make. So the basic premise is we use optical and satellite sensors to detect hotspots and smoke. And something that's been completely new for me now, whereas previously I ended up running pretty much data science only teams, and there was, you know, if there was a product, that was a completely separate team. This team that I run now, they build the infrastructure as well. So I've had to learn about deploying microservices architectures on the cloud. So you will also find in your careers, and I think Hugh talked about it a little as well, like, you go and you try something new, or you end up in a new application area, or you end up in a role that requires you to learn a whole bunch more skills about another technical thing, and you just rise to the challenge, because failure is not an option, right? you know you're smart enough to learn something new. So this has been a big challenge for me, is to learn along the way from people working for me who are much, much better at their specialized areas than I am. But under the hood, this is a little bit of, I guess, the pictorial elements of what the technical problem is. So on the left, inside the red circle, there's a yellow dot. So what happens with the satellite sensors, and this is, it's another link to astrophysicists. So this particular satellite algorithm, originally they started developing this when they had their sensors pointed out at the universe and they were looking for supernova, which was in some way providing evidence of the expansion of the universe. But it turns out if you turn those sensors around, some of the infrared channels, if you look at how they evolve over time and you're looking at a stationary spot on the Earth, you can see hotspots that could be indicative of fire. And so that's what the satellite sensors do. And then we use the cameras. As you can see here, there's a couple of shots from, I'm going to say they're both in California. But we've got a smoke detection algorithm. I mean, this is a reasonably sensible and standard application of computer vision models. Is we have a series of images that we take because we're observing some kind of forest scene, and we're just looking for things that look like early smoke. So at the top you can see a really good one. The top on the right, that's a really good early smoke. Then we have this other funny thing that happens sometimes because they're up on fire towers, is we get beautiful pictures of eagles. So that's why I like to include that one. But I'm sure that you can imagine with any kind of computer vision problem, you start layering in all of the complications of small data sets. Well, we've got millions of images. We've got very few examples of smoke. Well, of the kind of small smoke that we're really interested in. So this fire, if it goes on to develop, we're not really interested in a fire that's 12 hours old because we want to detect it in the first few minutes. So getting sample images is always a challenge. Getting confounding things like smoke, not smoke, drift smoke, that's a confounding thing, but clouds or fog or sun glare, like there's all these sorts of things that make it actually a much more complex computer vision problem than it first seems. And like I said, we make it available in a nice, easy to consume digital map. So this is one of the earlier versions of the software. So one of the things that happened this year, so Fireball International incorporated towards the end of last year. So bringing together what was Fireball Technologies with this satellite technology and building a front end. So we went from a working prototype of a smoke detection algorithm at the end of last year to a product that is now in the hands of paying customers. But like I said, this is one of the slightly earlier versions of the detection map. But you can see wedges on it that that are detections of different grades, and you can see a panel on the left that you can click through and see images from the actual cameras. We get satellite overlays now. It's become quite an amazing thing. And as I said before, like previously, the teams I'd managed were just data science teams. And so I have this like pretty strong mental model that when you're doing any kind of statistics or quantitative model, like we all think about, you get in your dirty data, you store it somewhere, and then you've got to do a whole bunch of filtering and pre-processing to make it clean. And then you go away and you train your model, whether it's, a standard statistics model or, the current state-of-the-art kitchen sink deep learning model. And then you train it and you work out which are the best parameters, and then you work out how to run it. But in my head, there was always up until this year, there was always a separate team that handled what users see or how users interacted with it. And I was literally just working in my comfort zone, working with a team, building the model, and just, once it gets to user interfaces or hosting architecture that was kind of out of my hands. So that's how I used to think about it. Now, actually, when we put these things into production, we have a training cluster, which is kind of how I used to think. That's my old comfortable world where we got to go and collect a bunch of images that are, you know, sitting in our giant terabytes of data. And we've got to set them up so they can be annotated. We have a human that annotates our images for the interesting bits. And then we do that standard stuff that we're all comfortable and familiar with around, you know, developing a model and training and testing it. And then we've got this whole production environment. And these were all new things that you don't really, when you're in academia, there's not a lot of call, in my personal experience, to worry about other people using your stuff. Although I used to admire, actually, in the statistics department, there seemed to be a lot of people who, as part of their PhD, would actually write and release statistics packages in R. And I think, you know, that happens now out in the commercial environment. I see that happen when people write packages for Python, if it's not IP protected. But, you know, that whole idea of how do things run in production, that was not something I'd have to think of before. And these are all skills that you can acquire on the job. And there's lots of skills that we need. And there's lots of skills that you continually pick up, right? Like you can, as a statistician or mathematician, easily rebrand yourself as a machine learning engineer if you polish up some of your software skills or have any kind of affinity for that sort of stuff. But then everything else, I think you can learn. So we have a technically diverse team. This is, you know, clearly during COVID time, we did lots of remote sessions together. And I'm going to say, you know, probably a quarter of these people are data scientists, another quarter are astrophysicists. And then we've just got a range of people from technically diverse backgrounds who come in and, like, you can always adapt what skills you have and leverage off your network to get these sorts of jobs. So I think my 15 minutes is up and I may have gone over time. I'm really sorry. I do want to say, like, I find it really interesting people use these buzzwords like, you know, these are the big new areas, but I actually think it's old stuff that we know, right?
Thank you, Ruth. It was very interesting to hear your career journey and also the important solutions that your team is creating. Yeah. So we will have invite you all to write your questions in the chat, and also to ask questions in person if you want after our presentations. All right, thanks, Ruth, again. I would like to introduce our second speaker now, Sharon Aude. Sharon is Head of Data Solutions at Australia Post, a role in which she creates new business value from data. After gaining qualifications in math, statistics, operations research, and genetics, Sharon went to work in industry. She has had many interesting roles in which she gained skills in designing, building, transforming, and operating digital businesses, and managing projects and teams. Welcome, Sharon.
Thanks, Luca. So thank you very much for the opportunity to be here. I hope you're all enjoying the retreat so far. I am going to start off with the timeline of my career also. I've had a long and varied work history, and this has really shaped my perspective and certainly shaped the key messages that I'll be sharing with you today. I graduated from high school in 1983, so a long time ago. And then I completed my Bachelor of Science at the University of Melbourne with a major in maths and population genetics. That led to my first role at La Trobe University as a research assistant in population genetics in 1987. But I did not love that job. I did not feel passion for that job. So 2 years after, I changed career and joined National Mutual Life Association. I joined the actuarial department and began a career in actuarial. Sad to say that I also did not love that. But I did look over the fence at the cool kids in marketing who were doing some pretty cool stuff, working on some new products, and decided to join them. And that began a career in strategic marketing and market research that lasted for a decade. I got to do some cool stuff. I joined Eastern Energy, a utility company, and then I shifted to the consulting side at Roy Morgan Research and AC Nielsen. I spent my time doing trend analysis, cluster analysis and segmentation, customer satisfaction regression models, conjoint analysis to understand willingness to pay, and consulting to industry. And I absolutely loved it. I did have some skill gaps, so my undergraduate degree didn't give me all the knowledge that I needed. And so I went back to night school and did a graduate diploma in applied statistics at RMIT. After 10 years in market research, I was recruited to join one of my largest clients, and that began another pivot in my career towards digital transformation and project management and working with emerging technologies and agile delivery. So again, I decided I needed a range of micro qualifications to formalize my on-the-job learning. I did a bit of a finance course called Finance in 5 Days, so I could understand financial statements, did some online digital marketing, certified as a Scrum product owner, and most recently graduated from the Australian Institute of Company Directors. And that led to my current role at Australia Post. And I've been to Australia Post for 2 years now. And I am heading up a data solutions business, which commercializes non-personalized data assets into the external market to help the community. So a long and winding road I have taken in my career, from research with Drosophila to working with Australia Post data. I've had lots of fun and learned a lot along the way, but it did make me wonder what career advice I would go back and give my younger self if I was starting over. And so I thought that's what I would share with you today. And none of this, as it turns out, is technical. It's all around the softer skills. My key piece of advice, number 1, is communication is key. So in the beginning, when starting out in your career, it's all very much about your technical skill and you've studied very hard for this. But in the commercial world, the career progression really requires exceptional communication skills. You need to be able to communicate your hypotheses, your ideas, your findings to other people. And very often they are, have no understanding and they're not technical and they don't understand your specialty area. You'll need to be able to influence for funding, for initiatives, or even for research grants if you stay in that space in order to make a difference. You'll have to motivate and lead teams of people and get them to believe in and act on your analysis. So IAPA, the Institute of Analytics Professionals at Australia, they this year named the General Manager of Data Science at Australia Post, who's my boss, as the top analytics leader in this country. Now, prior to Australia Post, he had progressed through the ranks of one of the big 4 accounting firms, where as a consultant, he honed his skills in storytelling and influencing change. This is his point of differentiation. The managing director of IAPA stated, leadership in analytics is so much more than technical expertise. Soft skills continue to be the difference between good and great, while the ability to crisply distill and translate analytics insights to business impact creates standout leaders. At Australia Post, we have about 25 data science engineers and data product managers. And the career path starts from entry-level roles through to senior data scientists and engineers, then to a team manager, onto a head of a function, and then finally the GM at the top. All of these roles have the base assumption of excellent technical skill. The differentiation and the progression comes through the ability to communicate with business stakeholders, influence for change, manage projects, and leadership of others. So if you aspire to a commercial career, you must hone your communication skills. For many of us, introverted analytical types, this can be pretty uncomfortable, even more so if you're not communicating in your first language. So it's really important to take courses in public speaking, accept speaking opportunities, ask for feedback, find a mentor who is good at it, and practice, 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 just like I'm still doing here today. My second key message is to embrace opportunities. So if you already know what your career path looks like, that's great for you. But if you don't, it's also okay. I'm this far into my career that started way back in 1988, and I still don't know what I want to be when I grow up. The value in having an analytical formal qualification is that it can take you in so many different directions. As you saw from my career timeline, I have had several career pivots, none of which I could have predicted, and all of which have led to something positive and fulfilling. And as Ruth mentioned, data and analytics is finally having its day in the sun. It's the sexy thing to do. So following the 10 years that I spent working in market research, I was at that point in time searching for a different work environment to better juggle my work and my personal obligations as a single mum. Through my client base, I was offered a role at a bank, which you saw, ANZ Bank. And when I first joined, I kind of felt like it was a step back. But, you know, ultimately, that role subsequently opened the door for me for a 13-year diverse career in digital transformation and product management that I could never have imagined. Although it took my career a bit away from data analysis, what it did do was expose me to new technologies that were not around when I was young, and they're critical to the world today. So it allowed me to stay relevant, it kept me stimulated, and it made me a more diverse and better leader. Career advice number 3, find passion. So for me, this is not about finding the single passion in your life and turning that into a job so it feels like you're not going to work each day. It's more about finding your passion within the role that you have at the time so you can immerse yourself into it. It's also about knowing which roles to turn down because you recognize that you will not find your passion there, just as I stepped away from the early career roles that I had. At Australia Post, I have created my own passion in my current role. When I first joined 2 years ago in a role to run just a BAU business, it was difficult for me to see my passion because it didn't have the transformational elements in the role that normally keep me energized. Also, I was new in the industry and the environment, it's a logistics business, so it was very different from the 13 years that I'd spent in banking. And so I spent the first 12 months learning about that new environment, building new relationships and laying the foundation within my business unit. And while I was doing that, I actually converged on where I would focus my energy and passion within the business. Since then, over the last 12 months, I've created a growth agenda in data solutions that will serve the community and produce profitable revenue for Australia Post. And it's around leveraging the many existing non-personalized data assets across the enterprise, but also leveraging the physical data assets to create new data sources. And so, you know, just by keeping my mind open and learning about the things around me, I was able to find my passion within the job that I had. Key learning number 4, be curious. So you have your formal qualifications in your analytical discipline, and that gets you in the door, but you must keep learning both on and off the job. Things change so quickly. So technology has changed from local computing to cloud computing, leadership styles from directive to collaborative, project delivery methodologies have changed from waterfall to agile. It's very important to stay relevant. For me, I've continued with a range of formal and micro qualifications to gain new skills. I talked about my postgraduate diploma in applied statistics when I was doing data analysis. But in my commercial roles, I've done quite a few micro qualifications around understanding financial statements, agile delivery methodologies. I'm a certified Scrum product manager. I learned about digital online marketing through an RMIT online course, and most recently became a graduate of the Australian Institute of Company Directors. All of this was supplemented with a myriad of business leadership programs within the commercial organizations that I've worked for to help me be a good leader through change, different negotiation styles, all in the soft skills space, things that I didn't learn at university, but are very critical in navigating the commercial arena. So it's really important to keep up with change. Certainly, I could not have imagined that when I was presenting my honours thesis back in 1987 on an overhead projector like the one on the screen here, that in 2020, I would be presenting to you from a laptop in my home in Melbourne over a virtual conferencing tool. So the change that has gone on in my lifetime has just been phenomenal. It's really important to keep up. And number 5 is maintaining your connections. And Ruth talked about this as well. She talked about, you know, I think the jobs that she's had have all come through her connection, through her network. And so this is critically important, that you remember to invest time and energy in maintaining your connections, because you just never know when you might need them. And when you do take the time to connect, you always feel re-energized. Maintaining connections has never been more important than during this time of working remotely, where our work days morph into our personal lives and we lose track of time as we work on a complex code or our algorithms, or for me on a business case. Your connections are the people that you turn to help you solve problems when you get stuck, and also they'll hire you and recommend jobs for you. I am notoriously bad at this piece of advice. I do not allocate time for it. I once had a career coach who suggested that I keep a post-it note stuck on my computer as a constant reminder to set myself the goal of blocking out time once a week to maintain a connection, but I must confess that I've failed. But perhaps you can all do better. Maintaining connections, you know, it can be done informally through coffee catch-ups, post-work dinners, drinks, getting active on LinkedIn. Ruth talked about hackathons, and you know, whatever feels most comfortable for you, but very important to do it. So there are the 5 key messages that I wanted to leave with you today about your career and investing in your career. None of them are technical in nature. Yeah, you've done your study and you've got your technical skills, and really what then becomes important when you're in the commercial world is a range of softer skills and your engagement with people and communicating your messages. And I didn't realize that when I first started out, and certainly it's something that I've had to learn along the way. And so I wanted to share that with you today.
Thank you very much, Sharon. It's always nice to hear from someone who's passionate about their work. And also thanks for the advice for us students and the early career researchers. Okay, I would like to introduce our third speaker, Aude Vignelles. Aude is the Executive Director of the Australian Space Agency. Trained as a space and aeronautics engineer, Aude started her career at the European Space Agency in the Netherlands. She has 25 years of experience with large and complex programs, introducing new technology in the telecommunications, space and media industries. She's growing Australia's space ecosystem and creating new jobs. And she told us that there are great opportunities for quantitative scientists. So, all the floor is yours.
Thank you very much, Luca, and fantastic presentation so far. I wish I had this kind of speakers when I was looking for my career and have a retreat like the one you're having now. It's been really interesting to listen to the previous speakers and you as well this morning. And lots of words resonate for me: passion, curiosity, definitely things that that are important. The presentation I'm proposing to run through today is more about what space offers for you. I'm doing studies in math and statistics. Quick word about me and my career and how I ended up here. I guess when I was a kid, I was very curious about how things works, you know, wanting to dismount a radio post because I thought there were people in there and I wanted to understand how it worked. And then there was no people, there was just electronics and boards. And so I'd always wanted to understand how things happens and how are things possible. So of course, math and physics and science and biology were a great interest to me. And the problem I had is I was so curious and so interested in everything. And I realized that space was probably the place where you can do a bit of all of that. So I've been also very lucky growing up in Europe when the ESA was being created and Ariane, the launcher, was being built. And I was lucky enough as well to attend the first launch of Ariane in '74. And I have to say, when you're a kid and you see that you attend a launch and you have the vibration of that launch in your stomach and seeing 14 different nations working together to make that launch possible, that was extremely inspiring. And I think that that day I caught the space bug. And when you catch that bug, you can't get rid of it, and you have to work in space by any means necessary. So I studied space system engineering. I did engineering school in France, then ended up in the European Space Agency, became an expert in testing all the scientific spacecraft that the agency was delivering. And at that point, the scientific spacecraft were like monsters of 5 tons and 10 meters high, far from the CubeSat we're talking about today. Having said that, we need a bit of both. And then I moved to London to change a bit and see what was my interest, and to see as well what it was to work in another country and to work in the industry. And I spent 4 years working in broadcasting, so still satellite and terrestrial broadcasting, so it's still a bit of a space in there, but also a lot of data already that was accumulated by all the pay TV channels that are trying to see which channel you're browsing and etc. And then came in Australia for a year, and 20 years later I am still in Australia and loving it. But during the 20 years, 18 of which were frustrated because no space agency in Australia, when there is really everything you need to have a successful space agency. So I've been doing everything I could in writing white papers and participating to panels and events and talking to our Prime Minister when I could, to lobby for a space agency. So when the space agency was created, I had tears in my eyes. And when they were looking for a CTO, I applied. And when I was chosen, I had more tears in my eyes. So I dare say I'm having my dream jobs today. And the agency is now has just turned 2 years old. And it's just the beginning of lots of successful stories that we have just starting delivering. And what I want to share with you today is what we're doing, what we are looking to do in the future. And you're gonna see that there is probably not one area where math and statistics and probability and data science is not applicable. So lots of choices for you in your career tomorrow. So next slide, please. That was a long introduction, sorry. The interesting things about the Australian Space Agency is we are not ESA, we are not NASA, we will never be a big agency like that because we have a very industrial focus. And our purpose is really clear. We want to triple the size of the industry and we want to create 20,000 jobs by 2030. And funny enough, when we talk to NASA and ESA, they're telling us messages that are very, very kind. First of all the space agencies in the world were very welcoming and overwhelmed when we got created, which was really, really good. But NASA is telling us we're lucky, one, because we are small and agile, but also because we don't have a specific space industry to support. Our goal is really to look into our skills and our competitive advantage in Australia and open a new market in space to an existing industry today. When NASA has to feed 4,000 industries that are only doing space. So they have a very strong burden that we don't have. And ESA was telling us as well that with new space and Space 2.0 today, role of agencies are to implement a strategy, but let the industry implement that strategy. And at my time at ESA, when we were doing the tenders, we were writing trucks of paper and files, defining the requirements of what the mission should be doing. Today, what they are doing is writing objectives and saying, we need a mission that's gonna fulfill this objective, this requirement, up to you, the industry, to design the system that's going to do that. So that's us, very clear purpose. Every day when we have 1,000 things to do, prioritizing our work is to see, okay, is this going to create jobs and grow the industry? If the answer is, I don't know, we pick another task that is more fulfilling this purpose. Next slide, please. So the first thing we did 2 years ago, a bit over 2 years ago, we released and published our civil space priority and our civil space strategy. And this is available in our website, but these are the 7 areas that we decided to focus on, either because our nation needs it, or we have a competitive advantage, or we already have skills that are going to be easily translated into space. So the first 2, position, navigation and timing and Earth observation, no brainer. Look at the size of the land in Australia. We need PNT services. We need Earth observation tools to be able to manage our land better. So we are developing a roadmap to fulfill these needs. Something interesting about Earth observation, we are part of a lot of international organizations in Earth observation. And often we are the only country not having a space asset invited into this organization, because we've been using Earth observation data for 40 years. As you know, most of the Earth observation data are free, the Landsat, the Sentinel, the Copernicus, and we've been using this data for 40 years, and we became well renowned for developing application from data provided by space assets. You may have heard that Geoscience Australia is probably one of the best organizations in Australia that have access to these data and delivering products there. And funny enough, we're also working a lot with Fireball, with Chris Taylor. So it was really interesting to hear the presentation about Earth observation. Is all about how to aggregate the data and how to deliver an application that's going to make use to the end user. So extremely important to have good data scientists in Earth observation. PNT, same thing, a lot of data that you need to crunch together and being able to deliver an application. So you see just the first 2 areas of priority, there is already a lot of opportunities for you guys to find your way in. Communication technology and services. So as you know, we always need more and more bandwidth. So in space data, again, because of the size of Australia, communication via satellite is required for the last miles, and the 2 billion of people who have access to terrestrial services or fixed wireless services. So very important for satellite data being a communication, but also television. The other thing about communication is today we are looking into laser comm and optical comms, because the bandwidth is very interesting when you talk laser and optical. And for optical laser comm, you need blue sky. And guess what? We have plenty of that in Australia, except when there are bushfires, of course. But we are developing, supporting an initiative to develop an optical ground station network around Australia to support deep space communication and also communication with the moon. So lots of interest worldwide to what we are developing here. Also because we are in the southern hemisphere, we are covering a part of the sky that nobody else is. So this is why when you hear Voyager communicating with Tinbila and the ground station that CSRO is operating, we are the only one being able to do that. The next one, space situational awareness, is also an area where data is key. So space situational awareness is all about knowing the objects that are orbiting the Earth. And I invite you to search in YouTube a video that shows from 1956, when there was nothing orbiting the Earth, nothing at all. And then 1957, the first Sputnik satellite in October, November, the second one. And then you have a time acceleration scale showing up to today, when we have more than 20,000 objects orbiting the Earth that we know of, that we can track, in low Earth orbit, in geostationary orbit and above. So we need to be able to know where each object is at any point in time. We need to make sure that these objects are not going to collide with each other. There is a lot of debris out there as well, and debris can be paint of flakes, bits of flake of paints. It can be fairing from launchers that have been left orbiting the Earth for more than 40 years. These are uncontrolled objects. They don't have their propulsion system, and there is a high risk that they're going to collide with things. So to collect all these data, you have ground-based sensor, telescope, radars, you have space-based sensor. All these data need to be aggregated, conditioned, and then you need to run machine learning and making sure that you know how to use this data, but you need to know how to predict the orbit of a satellite. You need to be able to predict the probability of collisions. You need to be able to predict the maneuver you should be doing to avoid collision. And in the work we are doing around SSA, 80% is really around mathematical analysis and probability and statistics. And in Earth observation as well, I needed to add, and I think the Fireball was also really doing that as well. You need to make sure that when you take a picture, you're going to have the data you need out of it. So you also have a lot of AI starting to go into all these priorities area. Can my satellite take a picture now? If it's an optical picture, there is cloud, you don't take pictures. So you have a lot of data crunching as well in Earth observation on board the satellite. The other bucket is Leapfrog. This was really to capture everything we don't know yet, where we should continue developing our capability. And very quickly we realized that everything around space medicine and life science, Australia is quite advanced there for several reasons. Because of where we are and the sun and the cancer, we have developed a lot of radiation technology to measure how much radiation impact you have when you're treated from cancer. So there is a lot of similarity with the radiation that you get in space. We have also great experience with the Antarctic division, and that is in Hobart, supporting the Antarctic people who are cut out from the world for 9 months out of 12. So what does it mean? How do you support them when they are sick, and when mentally it's really hard to be isolated? So we are developing a new strategy called Space Life Science and Medicine, and I'm sure we're going to continue discovering other areas where that deserve an area on its own. Robotics and automation. So this is the experience we have from mining. Don't know if any of you had the opportunity to visit the Rio Tinto Mission Control in Perth, but when you enter that operation center, you have the impression to be in the Houston Mission Control. You have a lot of people organized in pods and remotely mining or remotely moving cars or trucks in Pilbara, that is 2,000 kilometers away. And I remember discussing with the mining pod, and they were telling me, so the Pilbara is far away, it's hot, it's cold, it's dark, it's harsh, it sounds really like space. And they were doing all their operations from Perth. And they were telling me we could be mining on the moon, that could make any difference at all, because we're used to what we're doing. Plus they are using communication via geostationary satellites, so they know how to cater with latency. And if we are going to the moon, and if we are building a gateway, and if we are building infrastructure on the moon, we're going to have to do that remotely and using robots before sending humans there. So we are looking into how to export this remote asset management expertise that we have into space to help going forward to the moon and staying there in a sustainable manner. The last area is access to space. Sorry?
Yeah, I think we're running out of time. If you don't mind wrapping up.
No worries.
And then we have time for questions. And also
Okay, that's all good. And access to space is really making sure that when we launch from Australia, we're doing it safely. So if you want, I will just go through one slide that is summarizing everything else that I'm going to say, so you can skip that, and the three after as well. Oh, this was just to show that we've engaged with a lot of other space agency. You can skip this too and go to the, I think it's, and again, and again, and again. Oh yeah, that's much more than that. And again, that's just the Artemis mission, Moon to Mars. That's more detail about to Mars, but there is one slide that is summarizes all that, and I'll go quickly through this. That's the one. This was just to summarize everything the agency is doing, to give you a bit of a flavor of where you can find opportunities. First one is the ISI, International Space Investment Initiative. So we had 20 million. We did a call a year ago, and we asked anybody who wanted to do an activity in space to submit. We were oversubscribed. It was really hard to pick only 10 projects, but we've selected 10 projects. Funny enough, most of them are in space situational awareness, and a couple of them are really around probability and decision-making tools, so really your domain. I invite you to go into our website. There is a list of these 10 ISI projects. You can see yourself which one are using a lot of mathematical and statistic and data science. I'm sure you'll be surprised. So this is the first set of programs we are delivering. In 2 years' time, they should all be done. The one underneath is SIF, Space Infrastructure Fund. So this is to make sure we are building the infrastructure that is going to help unlocking a lot of potential in Australia. So we're building a mission control in Adelaide. We're building a remote operations center in Perth. We're also dedicating the POSE supercomputer, and I'm sure you've heard about that because it's really supercomputing power to be able to crunch data and make sense of all this data. So we are sponsoring a bit that is going to be dedicated to space, Earth observation, space situational awareness, astronomy. So that's of interest to you, I think. Tasmania, we are upgrading tracking facilities, and we have yet to deliver the qualification payload facilities. We're about to launch this grant very soon. We're also building a space discovery center in Adelaide, so a Questacon that is only for space. So I'm welcome to visit this when that will be delivered. And last but not least, a year ago, day for day, our Prime Minister, Scott Morrison, went to the US and dedicated 150 million to the agency to collaborate with NASA to bring a bit of an Australian flag into returning to the moon. So we are almost on the phase with NASA to agree on what kind of mission that's going to be, and more announcements around this are going to be done. And I'll stop there.
Yeah, thank you very much. It's always, as a statistician, I can say it's always interesting to see what you can do with data. And let's see if there are questions in the chat. So anyone has questions? We still have about 4 minutes, 3-4 minutes to answer questions, and also this session will be followed by a tea break. We will have 10 more minutes to stay connected and ask questions to our speakers. I've seen quite a few messages in the chat, but I don't see any particular question at the moment. So I would ask you a question maybe. Referring to the organization, to you all, do you think there are any career opportunities for students and early career researchers with a mathematical, statistical, physical background? I would ask this question to all of you, Ruth, Sharon, and Aude.
Can you repeat the question?
So do you think, what are the career opportunities for us students and early career researchers with a mathematical, statistical, or theoretical physical background, for example, in your organization?
So in the space agency, we have some opportunities regularly. So I invite you to look at that. I think around space situational awareness and Earth observation, that's definitely going to be some needs very soon. Robotics, remote operation as well. So there are opportunities there. Again, look as well at what's happening in the industry, because when we're going to release our roadmaps, and the first one should be released in the coming months, we're going to identify projects along these 7 areas of priority, and industry is going to hopefully pick up a few projects and needs some support to develop them. So it's a very hard question to answer, because again, anything in space would need some data crunching at some point, and some probability and statistics. So just watch this space and make sure you're subscribed to the newsletter of the Space Agency. We're trying to give as many news as we can.
Thank you. Ruth and Sharon, would you like to say something?
I think you can see from my varied career, the opportunities for someone with a maths qualification can really be quite diverse. It actually trains you in a way of thinking. But if you want to pursue career in data science, data engineering, Australia Post certainly has a sizable data science department, as I shared, about 25 people with a career path, constantly looking for operational efficiencies within our logistics management. So very focused on improving the delivery processes for parcels, particularly when there's been a complete change due to the world events that are going on, that has driven a massive increase in online shopping and e-commerce that comes with a raft of problems. The data scientists at Australia Post play a very important role in analysing all of the data points that come in, predicting parcel delivery, and now their focus is shifting towards providing real-time interventions to actually redirect parcels and notify receivers. So great career opportunities at Australia Post, and certainly in the banking world that I have come from, massive amounts of data in banking. So it's really the career to have at this point in time. A great time to be having a maths degree or a statistical background, I would say.
Could I add to that by saying, like, on top of looking at all the jobs that are advertised or that on newsletters that you subscribe to or from your network, there's like a small set of skills that you might not have picked up in grad school that you might learn on the job if it's sort of an entry-level or mid-level role, or that you can pick up yourself through side projects or whatever. So Sharon explicitly showed us a bunch of training that she's done outside of her career to progress her career. I kind of glossed over little bits that I'd done. So when I was in Bali, I did a couple of like the data science certificates on Coursera just to make sure I had that updated thing. And there's a few other things, I think, like just a couple of add-on skills that you should pick up that make you more relevant for finding jobs, which for me would be, you need to know Python and you need to know how to use Git, because otherwise I can't put you on my team. But apart from that, if you've got a math degree or any kind of quant degree, I will interview you. I just, there's a couple of little add-ons that I'll need before I can put you on my team.
Yeah, good stuff.
Yeah, I think it's time for a tea break, so I invite you all to grab a tea or some food, and I will continue this conversation with our speakers. If you still have questions, just post them in the chat, and if we don't have enough time to answer the questions, we will send them to our speakers and get the answers back to you.
So Luca, we have a about innovation, and each of our speakers.
This question, we have an interesting question in the chat. Jesus says, innovation is risky. How do you strike a balance between ambition and delivering results? Who wants to start?
I've got something to say on that, unless you want to go first, Sharon.
No, mine will be quick because it's really a commercial decision in an organisation like mine. Innovation, you've got to find funding for it, so you've got to prove your case. So it's probably you have to influence a whole bunch of executives, and that's how it's balanced, really. Money.
I was going to say something quite similar, because it's really like you look at what your funding source is and what are your, like, you can't overpromise and underdeliver. I mean, our company just got a accelerating commercialization grant from the government, and you write down a set of milestones and your grant can be stopped if you fail to meet your milestones. And, you know, the way you balance your ambition between delivering results is like your bottom line. You know, like if you have no paying customers for the coolest little thing that you built, it doesn't matter, it's just your side project. But if you've got paying customers, then you work towards what they are paying for.
Yeah, I agree, Ruth.
Great question.
Yes, okay.
I guess for me, the answer is going to be different because innovation for space is different than innovation in the data processing side of things. So I understand very well what you just both said. Once upon a time, it was super expensive to launch a satellite in space. So you better be 100% sure of what you're doing before you do it. Now that space is kind of democratized and it's becoming more affordable to do your CubeSat and launch it. I think it's a dream world for innovation. Test fast, fail fast, and start again and discover great way to innovate along the way. So for whoever has an innovation spirit, I think being in space today is kind of the right time.
Great. I think it's now time also to get ready for the next session. So we will have separate sessions for students and ECR. I really want to thank our speakers and thank for the time you spent with us today. You're really grateful, and I think there's room for creating new opportunities for collaboration between the organizations and ACEMS as well. And I also want to thank Angela for her great job. She has helped us connect with the speakers and she helped us running some of the presentations. So thank you very much for your time, and we'll stay in contact with you.